But then there's people who end up homeless on the streets because they don't know what the hell.
So today's the 10th,
Yippee.
and we are graphing linear inequalities.
That's a big word or a big sentence.
I will just remind you that if you were to look back on Canvas, not that you would, like 3 months ago, we did a unit on inequalities. The kind of inequalities that we did were not like what we're going to do now. So you might remember, and do not write down what I'm about to write down. Just take a look at this and you'll be like, oh, I remember this. If we had a problem like 4 minus 3 um, x is greater than -2. Do you guys remember this?
Yeah.
How like we would subtract, and then remember how if we divided by -3, we'd have to switch the inequality sign?
Yeah.
So like you remember that we've been through this, right? But the thing is, when we did it the first time, we did it as just single variable, kind of we treated them like equations. What we're going to do now is we're going to do them in two variables, and we're going to do them on the XY plane. So even though a lot of people would refer to this as a linear inequality, and a lot of people would refer to what we're going to do today as a linear inequality, it's generally about the context in which you're doing what you're doing. So let's get started with something nice and basic. Let's say I gave you this. This will be hard for you to take notes, and honestly, this shouldn't take too long anyways. I think if I were taking notes in my own class today, I would more just try to piece it together and just try to grab some main ideas. There's going to be some key ideas like when to do dotted lines, when to do solid lines, and just a few key ideas. But I think you know the bulk of the skills necessary to get through this. So as we graph inequalities like this, the first thing we're going to do is we're going to think about normal. Hold on a second. I got to pause. It's hard for you because you don't have graph paper probably like I do. So just kind of follow along here. I'm going to just graph this like I've done 100 times before. I would start my graph at negative down 3, right? So I'm going to go down 1, 2, 3, put a dot. What's the slope of this line?
Up one, right two.
Up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. And I just want to make sure I get dots that are really far apart. You've heard me talk about this before. Graphing when your dots are close together is a recipe for disaster. Now, normally what we would do is we would grab our rulers and we would just make a line and we go like what did we go back in time or something like that? Well, here's the deal. Um, when you graph an inequality like this, you have to consider whether the line is normal or if the line looks like this. And I don't know. I'm just going to throw this out there. Does anyone want to take a guess as to what the dotted line means?
Um,
You mean if it had or equal to, do you think I would make the line solid?
Yeah.
Yeah, you're a pretty smart cookie. Let's pick a point on the line, and and by let's, I mean I'm just gonna go ahead and pick it because I want to, but does everybody see the point that I just turned green?
yeah.
Could you tell me the coordinates of that point?
110.
5, 6, 7. I believe it is 8, 1. So what I just did is I took a point on the graph and I brought its coordinates out because I want to try to teach you something. I try to teach this every year and I don't know what my success rate is. You could tell me when I'm done. In about 1 minute, tell me if it made sense or not. I'd like the feedback. What I want to show you is what happens when I test that point. And to test a point means to put its numbers in the problem and see what happens. So you would all agree if I test a point that's on my dotted line, right? That point was on the line, and 8 is the x and 1 is the y, correct? That if I transfer those numbers into the white problem down below, it would say this: 1 is greater than 1/2 of 8 minus 3. Does everybody see that I just changed x and y?
Yeah.
Now we got to do some little kitty math. What's half of 8?
4.
So I have 1 is greater than 4 minus 3. And what is 4 minus 3?
1.
And is 1 greater than 1?
No.
It is not. And this goes back to what Nash spotted in a pretty big hurry. And that is that by dotting the line, what I'm telling someone is that the points on the line actually don't work. They are infinitely close to working. What do you think would happen if I keep testing points? Like if I tested this one and this one and this one, what kind of expressions or problems or answers would I get?
Repetitive.
2 is greater than 2. -4 is greater than -4. -10 is greater than, I keep getting the same number, but because there's something missing from my problem, that's why I have to dot the line to tell people that the points on the line, they're imposters. They're really close, but they don't work, right? And again, excellent job catching that so quickly, Nash. So if this had been an or equal to sign, then I would have changed the line to solid because now all these 1 is greater than or equal to 1, 5 is greater than or equal to 5. Now they become true statements, so the line can be solid. Did that make any sense at all? So the dotted line has a purpose. It's a communicative purpose that says, I'm a boundary, but I don't work. Having said that, let's finish the problem now. So do you have any questions about just the construction of the boundary, the wall? All right, the last thing to do when you graph an inequality is to figure out what the answer looks like. And you might think like, oh, I thought we already did that. No, all we have is the boundary. The answer to the problem either looks like this or like this. You ever seen one of these before?
Nope.
So the question becomes, well, how do I know? Do I shade above the line, like the yellow, or should I shade below the line? And there are other answers to what I'm about to say. I'm going to give you the most professional version of this first, and then as we get more comfy, we will find shortcuts. But here it comes. If I want to know which side of the line all the true points are on, all I have to do is test a point. If I test one point and it works, then I shade that side. If I test a point and it doesn't work, I shade the other side. That's easy logic. The easiest point in the world to test is this red one right here. What's his name?
The origin.
0, 0, the origin. His coordinates are 0 and 0. So let's do the easiest thing anyone has asked us to do all day, and let's test the point 0, 0. If you put 0 in place of x and 0 in place of y, this math problem, this white problem, will now say 0 is greater than, what's 1/2 times 0?
Nothing.
What's 0 minus 3? Is 0 greater than -3?
Yeah.
It sure is. You know what that means? That means that the red point up there works, and by default, it then also means that every other point on that side works, and this is how you graph an inequality. Step 1, establish the boundary. Step 2, decide which side all the goodness is on. The boundary will always be definitive. One side all good, the other side all bad. Okay? Let's take a look at another one, and this time let's just do a little bit of work beforehand. So this time I'm not going to serve it up on a platter for you. I'm going to make you work for it a little bit. So let's do x minus 2y is greater than or equal to 4. What changed? Why is this one different than the last one?
Because y isn't by itself.
Y isn't by itself, so we have work to do. So what's the first thing we would do to get y by itself?
Divided by 2. Both sides.
No, you should not be dividing this early in a problem. I would move the x to the other side. I'm a y on the lefty kind of guy. Josh, I'm not opposed to moving that y either. That's another sort of personal preferencey thing that you could start doing. I just like my y on the left. I'm not going to lie. That's me. So I'm going to subtract the x. I'm going to leave the -2y here. I'm going to put that sign down. What's my right side going to say?
X minus 4.
Negative x and still positive 4, like that. 4 did not move. He stays plus. Now I'm ready to hear that other thing. What do? We divide by. And do you remember from that chapter a long time ago? I just said it a while ago. What happens in an inequality when you divide by a negative? It does flip. So we're going to have actually now y is less than or equal to, what's my slopey going to be? Nice job. And what's my y-intercept going to be? Yes. So let's get to graphing this. Where's my starting point going to be for this graph? Yep, down 2, right? Specifically. So I'm going to go down 2, and I'm going to put my first dot down 2. And what is my slope? Yeah, and I didn't mean for this problem to be like almost exactly the same. This time, am I going to graph a solid line or a dotted line? Why solid? Because it's got the or equal to. Very good. Yeah, we don't care about greater than, less than right now in the process. I just want to know, should I graph a solid inclusive line or a dotted exclusive line? And because it's solid or because it's or equal to, we're going to go solid. So by graphing a solid line, we are showing the reader of our graph that the points on the line are included. They work, they're solutions. And we're to the point now where we go, well, which side should we shade? And the answer to the question is test a point, right? So let's test this yellow point right here. Boop. If he's available, you should take him 100% of the time. Nothing easier than putting zeros in equations or inequalities. If you put zeros here and here, by the way, you should only test in the original problem, not this one. Why is that, do you think? Because we change stuff, and what do you think is the probability if you gave this problem to 100 people that at least 10 or 20 of them made a mistake? Pretty high, isn't it? So we don't want to use something that we created to test. We always want to go back to the original problem before we got our filthy hands on it. So if we put zeros in place of the X and the Y, what will the yellow box say?
Zero minus -2 times 0.
It's going to say 0 is greater than or equal to 4. You put zeros in place of the X and the X's and the Y's essentially just go away. You put 0 and just washes stuff out. Is 0 greater than or equal to 4?
No.
Of course it's not. That's a lie. So if the yellow point is a lie, guess what that means?
It's true.
It means that the other side is true. So if you test a side and it's no good, by default, promise you the other side will be good. That's the logic. Now, I quickly want to show you what this looks like in Delta Math before I conclude the lesson, just so that, so keep your Chromebooks put away. Give me just another couple of minutes. So this is what it looks like. And as you would expect from Delta Math, it's pretty dang user-friendly. So what's the first thing I have to do? Get the y by itself. Nice job. And so to get the y by itself, I have to move the 3x to the other side. So I get negative 4y is less than what?
-3x minus 4.
Negative 3x plus 4. The 3x moved, so it becomes negative. The 4 stayed, so it stays positive. Now what do we do? Yeah, and we divide in all the places. We go divide here, boom, divide, boom, divide, boom. And then we just got to be solid. So here it goes. Y is greater than, what's the slope? Yep. Nice job. So let's graph our boundary line first, and you'll see how easy Delta Math makes this. So what I'm going to do is I'm going to start by going to down 1, and I'm going to click a dot. You've done this before. It was a long time ago, but Delta Math just lets you drag this around to make a line however you want. What is our slope?
Right.
Up 3. 1,
Right,
2,
four.
3, right, 1, 2, 3, 4. Like graphing doesn't get any easier than this. Now you'll notice that there are 2 option buttons here. One of them is change the line. Do I want the line to be solid or dotted? It does not have the or equal to, so I'm going to hit change line and it changes it to dotted, which is pretty slick. And the last thing is changing the shading. The question is, should I shade here or here? It's just going to let me keep choosing until I'm ready to send it. I'm about to show you a shortcut. And if you use this shortcut, use it wisely. I want you to read something to me out loud, and I'm not trying to insult your intelligence, but I want you to read what I just circled. What does that say? That says is greater than. And if you follow your spidey sense, you know that greater than means above 100% of the time, correct?
Yeah.
So I'm inclined to just leave it like this and hit send. Some people might go back to the beginning of the problem and say, but hold on, the original problem was a less than, so shouldn't we shade below? And the answer is no. If you're going to use the shortcut, you can only use it after you get y by itself. Why is this dangerous, though, to use the shortcut? Because we could have screwed it up. We could have forgotten to change it when we divided by a negative, or we could get something messed on the wrong side or something. But if you feel solidly good in your ability to get y by itself 100% of the time, then you can base your shading on the greater than or less than that you get at the very end. So I'm just going to gamble here. Okay, I trust us. We remember to change the sign. We're good. It says is greater than means above. So I am going to submit it. I'm going to send it. And look, we did it. Okay. So you just have to be careful when you do this. You have to be confident. And if you're not sure, then do what I showed you in the lesson. Go and test the 0.00. If he's not available because the line goes through him, boo-hoo, pick a different point. But the idea is make a line, decide if it's solid or dotted, shade on one side. Do you guys have any questions about that? I do believe that you will see some vertical and horizontal lines scattered throughout. You'll even see some softballs where look like it's already solved for y. Are you kidding me? But I do think there are some horizontals and verticals in here. Maybe not. Of course, you'll probably get one first. I can't find one, but you'll probably find one. So that is the lesson. I could make this take longer, but do you get it?
Yeah.
I mean, it's what we've done before, right? Get y by itself, graph a line, solid, dotted, shade aside, boom. So let's do this. Delta math. Stay on task, okay? Nothing else.